All right, today we are looking at the quadratic formula. This is what we use to solve quadratics when we cannot solve by factoring. So if you have your quadratic in standard form, ax squared plus bx plus c, we can use this special formula, negative b plus or minus the square root of b squared minus 4ac over 2a, to find our two solutions for the quadratic. This is a formula you will need to memorize, and we are going to go through some examples today to get you some good practice with that if you're not already familiar. So on problem A, we already have our equation in standard form, so we don't need to move anything. So the first thing I'm going to do is identify what my A, B, and C values are to help me better locate them in my formula. So A is going to be 1 here, B is 4, and C is also 1. So now that I know A, B, and C, I'm going to put them all in their respective locations in my formula. Starting with negative B, that's going to be negative 4 plus or minus the square root of B squared, that would be 4 squared, minus 4 times A is 1 times C is also 1 over 2A, which is 1. So negative B plus or minus B squared minus 4AC over 2A. Once you have everything in your formula, you're just going to use order of operations to simplify. Let's start with what's inside my radical. That negative 4 outside won't change. 4 squared is 16. Negative 4 times 1 is negative 4. My denominator is 2. So I'm going to have negative 4 plus or minus the square root of 12 over 2. Now, 12 is not a perfect square, so we want to give our answer as a simplified radical. We do not want decimal answers. So the square root of 12 does have a factor that's a perfect square. That would be 4 times 3. So this simplifies to be 2 square root of 3. So negative 4 plus or minus 2 square root of 3. I can simplify this expression further because the negative 4 and the 2 in the top are both divisible by my denominator, which is 2. So this final answer in simplified form is going to be negative 2 plus or minus the square root of 3. And when you have an irrational answer, that is how you're going to leave it, as a simplified radical, no decimals. Okay? On example B, I do need to move this 2x to the opposite side so that I have my equation in standard form. And now I'm ready to identify A, B, and C. A is 10, B is negative 2, C is negative 1. I'm going to plug all those values into my quadratic formula. The negative of negative 2 is positive, so negative B is going to be positive 2. Plus or minus the square root of b squared minus 4 times a times c all over 2a. So again, now that I have all my values in their correct location, I'm going to simplify what's inside my radical first. So negative 2 squared is 4. Negative 4 times 10 times negative 1 is going to be positive 40. Over 2 times 10 is 20. So I'm going to get 2 plus or minus the square root of 44 over 20. Again, 44 is not a perfect square, so let's see if we can simplify it. A factor of 44 that's a perfect square is 4. So that simplifies to 2 square root of 11. And so in the top I have 2, 2, and 20. Those are all divisible by 2, so my final simplified answer is going to be 1 plus or minus the square root of 11 over 10. And I'm going to leave it in exact form. So when you see something say give your answer as an exact answer, that's what it means. Leave it as a radical. Do not type it into your calculator and get a decimal answer. Okay, on to example C. I do need to move that 117 over so that my equation is in standard form. And now I'm ready to identify A, B, and C. A is 2. B is negative 5, C is negative 117. So x is going to be negative b. If b is negative 5, negative b is going to be positive 5, plus or minus the square root of negative 5 squared minus 4 times 2 times negative 117, all over 2 times 2. Again, order of operations, start with what's inside my radical. That is going to be 25. Negative 4 times 2 times negative 117 is 936 divided by 4. 936 plus 25 is 961. And that is a perfect square. The square root of 961 is 31. So I have 5 plus or minus 31 over 4. Now, this is going to give me rational solutions. These values are going to simplify to give me either a whole number or a fraction. So we're going to find our two solutions by first adding 5 to 31. 5 plus 31 over 4. That gives me 36 over 4, which is 9. Then I'm going to subtract the 2, so 5 minus 31 over 4. That is going to give me negative 26 over 4, which reduces to negative 13 over 2. So my two solutions are 9 and negative 13 over 2. So that's what the plus or minus means. It means you find your two solutions by adding the values in the top and dividing by the bottom, and then subtracting the values in the top and dividing by the bottom. So if your radical ends up being a perfect square, you can simplify your answer out into your rational solutions. If it's not a perfect square, that's where you leave it in simplified radical form. Okay, last one on this side, problem D. I need to move everything to the same side so that I have my equation in standard form. Now I can identify A as negative 1, B as 8, and C as 84. So x is going to be equal to negative 8 plus or minus the square root of 8 squared minus 4 times negative 1 times 84 all over 2 times negative 1. So simplifying what's inside my radical, that's going to be 64. Negative 4 times negative 1 times 84 is positive 336 divided by negative 2. It's going to be negative 8 plus or minus the square root of 400 over negative 2. 400 is a perfect square, so that's going to be negative 8 plus or minus 20 divided by negative 2. So I do have a perfect square, so I'm going to get rational solutions, which means I'm going to finish out this operation. Let's start by adding. Negative 8 plus 20 divided by negative 2. That's going to be 12 over negative 2, which is negative 6. Negative 8 minus 20 over negative 2, that is negative 28 over negative 2, which is positive 14. So negative 6 and positive 14 are my two solutions. Okay. All right, so that is solving our solutions. The next thing we're going to talk about is our discriminant. The discriminant is b squared minus 4ac. That's the part that is inside the radical in our quadratic formula. And our discriminant can actually give us a glimpse as to what type of solution we're going to get from a quadratic. So we're going to do kind of a discovery activity next. We're going to look at the 5 problems on this page. We're going to find the discriminant, use our quadratic formula to solve for the solution, and then when we're all done with the problems, we're going to circle back and look at a pattern that we see. Okay? So, and just to have this handy, I'm going to put my quadratic formula at the top. And the more that you use this, the easier it will be to memorize this formula. So let's start with example 1. I want to find my discriminant, b squared minus 4ac. So I do need this equation in standard form, so I'm going to move the 16 over. And now I'm ready to find my discriminant. So b squared, that's going to be 6 squared minus 4 times 1 times negative 16. So that's going to be 16 plus, I know it's going to be plus because I have a negative times a negative. 4 times 16 is 64. 16 plus 64. Oh, that's not 16. I apologize. 6 squared is 36. Don't know what Miss Treadway was thinking here. 36 plus 64. That's going to be 100. So my discriminant is 100. Now, let's finish out our quadratic formula and solve number 1. So x is going to be negative 6 plus or minus the square root of my discriminant. We already calculated b squared minus 4ac, and I know it's 100. all over 2 times 1, which is 2. 100 is a perfect square, so I'm going to have negative 6 plus or minus 10 over 2. So I'm going to get my two solutions. Again, negative 6 plus 10, that's going to be 4, divided by 2 gets me positive 2. Negative 6 minus 10 is negative 16, divided by 2 gives you negative 8. So there are my two solutions, positive 2 and negative 8. All right, let's look at number 2. Again, I want to find my discriminant. This is already in standard form, so I don't need to move anything. So my discriminant is going to be b squared minus 4 times a times c, and 4 squared is 16. Negative 4 times negative 1 times 8, that's going to be positive 32. 16 plus 32 is 48. So there's my discriminant. Let's finish solving with our quadratic formula. X is going to be, the negative of negative 4 is positive 4, plus or minus the square root of my discriminant, which I already found to be 48, divided by 2 times negative 1. So 48 is not a perfect square, so I'm going to simplify it. It's going to be 4 plus or minus 4 square root of 3 over negative 2. And this is an irrational solution, so I'm going to leave it as an exact answer with my radical, but I can divide everything by negative 2. And so my final solution is negative 2 plus or minus 2 square root of 3. Okay, on to the next one, number 3. It's already in standard form, so I'm looking for my discriminant. Negative 24 squared minus 4 times a times c. These are going to be big numbers. Negative 24 squared is 576. Negative 4 times 18 times 8 is minus 576. So this is going to give me 0. So my discriminant is 0. Let's find out what our solution is. 24 plus or minus the square root of 0 over 2 times 18. Well, the square root of 0 is 0, so this is going to be 24 plus or minus 0 over 36. 24 plus 0 is 24 divided by 36, as a simplified fraction is 2/3. 24 minus 0 is 24 divided by 36, as a simplified fraction is 2/3. On to number 4, already in standard form, let's find our discriminant, b squared minus 4 times a times c. That's going to be 16 minus 40, which is negative 24. So my solution is 4 plus or minus the square root of negative 24 over 2 times 2. I can't take the square root of a negative number, so this is going to have no real solution. All right, and then last but not least, I do need to move that 8 over so that I have my equation in standard form. My discriminant is going to be 4 squared minus 4 times 3 times negative 8. So that's going to be 16 plus 96, which is 112. So my solution, 112 is not a perfect square, so I'm going to simplify it. And then this can all be simplified further because everything is divisible by 2. And there is my solution. So let's circle back and look at our discriminant and the solution we got. On number 1, our discriminant was a perfect square. And our solution was 2 real rational numbers. So we got 2 real rational solutions when our discriminant was a perfect square. On number 2, our discriminant was a non-perfect square. And we got 2 real irrational solutions. On number 3, our discriminant was 0, and we got 1 repeating solution. And on number 4, we had a negative discriminant, which meant I had no solution. And then lastly on 5, again we had a non-perfect square, which meant we are going to have 2 real irrational solutions. And that is how you can use your discriminant to predict the type of solution you're going to have. So either a perfect square, non-perfect square, 0, or negative number. And that concludes our notes on the quadratic formula today.